Okay, now that we have a general sense on how to solve for x problems, I want to take you through a couple practice problems that are a little unique and may throw you for a curve. So I want to address it right off the bat here. I'm going to go through these pretty quickly, so feel free to pause or rewind if you need to. Let's start with this one here. 5x equals 20. So remember, when two numbers are right up against each other and there's no symbol, this is a multiplication. So another way that's saying this is 5 times x equals 20. So really what this is asking us is, hey, what number, since this is a variable, what number needs to be multiplied by 5 to get to 20? Now again, maybe some of you already know that, but we want to show you the steps to take so that you can show your work. Now, as I said, this is a multiplication problem. And in order to solve these solving for x problems, we need to do the opposite operation. The opposite of multiplication is division. So I'm going to divide everything by that number that it's being multiplied by. So I'm going to divide everything by 5. By dividing everything by 5, my 5s are going to drop out because basically I'm saying, hey, I'm going to multiply this x by 5, and then I'm going to divide it by 5, which is going to leave that x all by itself. Now, I can't just divide the left side by 5. That would make my scale uneven. I need to divide the right side by 5 as well. So my x is isolated, which is what I wanted. Now I just need to do some computation. What's 20 divided by 5? That is 4. There's our answer. And we can double check. 5 times 4 is 20. We're good there. How about this problem over here? X over 4 equals 3. Well, what operation does this fraction line represent? It represents division. So my x is being divided by 4. So I need to do the opposite operation, which is multiplication. And this is the way that I want you to show it. I'm going to multiply everything by 4. I'm going to put in parentheses to show that I want to multiply by 4. If I'm dividing something by 4 and then multiplying it by 4, it's going to leave me with that one variable isolated, which is what we want. So my 4's are going to cancel each other out. I'm going to be left with x all by itself. That's what we wanted. But I've got to remember that if I do something to the left side of my equation, I got to do it to the right side so I keep everything even. So I'm going to multiply by 4 on the right side as well. Now I just need to do some computation. 3 times 4, that is 12. And there's my answer. X equals 12. Two more problems. X, nope. Gotta get a better eraser. Okay. 5 plus x equals 17. Oh my gosh, Tyler, we've been dealing with problems where the x comes first. What am I supposed to do with this number over here? Well, you're going to do the same thing, but we got to think about our opposites here. So 5 plus x. So I am doing some addition here, but really what I'm trying to do is get rid of this 5, and it's a positive 5. I got to get rid of this 5 so that x is all by itself. Well, to get rid of this positive 5, I'm just going to take it away. So I'm going to subtract 5 so that 5 minus 5 is equal to 0, which would leave me with x all by itself. That's what we're trying to do. We're trying to peel away these layers so that we get x by itself. And we got to be really flexible with our thinking here. How can I get x by itself? How can I get rid of that 5? And I do that using the opposite operation. This is a positive 5, so I'm going to take that 5 away. But if I take a 5 away from the left side, I got to do the same thing to the right. My 5's are going to drop out, leaving me with x all by itself. That's what we wanted it. We wanted it isolated. 17 minus 5, that is going to give us 12. And 12 is our correct answer because I know that 5 plus x, in this case 12, 5 plus 12 equals 17. Check. One last one. Let's do 12 equals x minus 8. Oh my gosh. Tyler, we've only been dealing with x's that are on the left side of the equation. Yes, but that doesn't matter. We can use the same methods to get x all by itself. So how are we going to get x all by itself? Well, right now it's being subtracted by 8. The opposite operation of subtraction is addition. So I'm going to add 8 to the right side. And same thing, if I do something to one side of my equation, my equal sign, I got to do it to the left side, to the other side. So my 8's are going to drop out, leaving me with x all by itself. 12 plus 8 is 20, and there is my answer. Even though x is on the right side, that's okay. We know that x equals 20, and we can flip it around if that makes us feel better. Okay, so I wanted to show you that the x can be on either side of the equation. We still follow the same methods. Thanks for listening.